Welcome back, everybody. Our next speaker is Eliza Thomas. Eliza came to us from coastal New England, which is a common theme among this cohort, where her delight for marine ecosystems flourished as she grew up sailing and exploring Maine's rocky intertidal. After spending 2 months at sea in 2016 researching the effects of climate change on the South Pacific Ocean, she knew she wanted to build a career in marine science and conservation. She's a big systems thinker who, before joining this program, worked in coastal resilience research, reef restoration, and conservation advocacy from the Bahamas to the Chesapeake Bay. Eliza noticed a disconnect between marine research and effective policy and management, and shifted her focus to bridging this gap and applying large-scale ecosystem research to climate change policy. I know when Eliza was thinking about a capstone project, she wanted to do something that was really at the forefront of what's happening in our ocean right now, today, and what is the dynamic issue that really needs all hands on deck. Eliza really is an inclusive, thoughtful thinker when it comes to finding strategies to deal with things like climate change in the ocean. And it wasn't a surprise at all to find that she landed on something so relevant right here in the States and right off of California, like offshore wind, that people are already, when we went to Sacramento, people were already so excited to learn more about her project because it really is at the leading edge of this issue. And I'm really excited for her to share her research with you today. So the title of Eliza's presentation is Mind the Gap, Strengthening Baseline Ocean Monitoring in California to Understand the Impacts of Floating Offshore Wind Developments. Welcome, Eliza.
I grew up in New England, and I spent much of my childhood exploring this stretch of rocky coastline in Maine. And when I was a kid, the water was so cold that I couldn't stay in for longer than 30 seconds without getting a brain freeze. Now I can comfortably swim for about 20-25 minutes. And yes, I'm probably a little tougher than my 6-year-old self. But my point is that decades of familiarity with this cove as a child and young adult gave me a strong baseline understanding of the typical water temperature. So when I compare my experience as an adult to this baseline, I can really feel how this corner of the ocean has changed. And while my experience is subjective, long-term monitoring of the ocean provides the objective data to confirm what I've personally experienced. And the data says it's true. Over the last 3 decades, the temperature in this cove has risen by 4 degrees Fahrenheit. Because the ocean is naturally variable, long-term monitoring provides a baseline that enables us to identify changes in the ocean environment that are not natural, like changes due to climate change or human activity. And today, I want to share with you how long-term monitoring goes beyond tracking the water temperature in Maine, and it's playing a key role in one of the most contentious issues in California, and that's offshore wind energy. California plans to build the 2 largest floating offshore wind farms in the world. Together, they will occupy 583 square miles of the coastal ocean, which is about twice the size of New York City. In this area, there will likely be about 1,600 wind turbines, spaced a 1/4 mile apart from each other, each the size of the Eiffel Tower. These wind turbines will be massive and densely packed, and once they're up and running, they will generate 4.6 gigawatts of electricity to the California grid, powering 1.6 million homes, and reducing California's reliance on fossil fuels. The 2 wind lease areas are roughly 20 miles offshore of California, one off the central part of the state, off of Morro Bay, and the other off the northern coast. The different colors here represent the different energy companies that possess the offshore leases, but all you really need to know is that 2 big wind energy developments are coming to California. And from start to finish, the process is estimated to take about 10 years. If these estimates are accurate, we're about halfway through, beginning the site assessment process, with construction beginning in about 5 to 7 years. Now, offshore wind is not a new concept. Countries, including the US, have utilized this technology for decades, giving scientists some understanding of the ways that these structures impact the marine environment. But California's offshore wind farms will be built differently, which means that their environmental impacts will probably be different as well. Using the Morro Bay wind energy area as a case study, I assessed the state of oceanographic and ecological baselines in the area to try and identify places where baseline monitoring needs some additional support. After all, baseline monitoring is going to be critical to understanding the impacts of how these floating offshore wind developments impact the marine environment. California requires this new floating technology because just a few miles offshore, the continental shelf drops off pretty significantly, which means that these wind turbines will be in water as deep as 1,000 meters. And that is way too deep for the standard wind turbines that you see on the left side of this figure, the monopile and jacket designs that are used all over the East Coast and elsewhere in the world. The 3 floating water designs are new, using long cables to anchor the turbines to the seafloor. And this floating technology has only been used a handful of times across the globe, but never in waters this deep and never on such a large scale. So because of this, the potential impacts of these structures on the surrounding marine environment is pretty speculative. And this leaves California with the opportunity, and I think the responsibility, to really study the impacts of this floating technology. Luckily, the coast of California is one of the most well-monitored parts of the global ocean, with dozens of long-term monitoring programs operating in the area. Just a few of them are listed here. And this includes the longest-running ocean monitoring program in the world, CalCoffee, which has been consistently sampling the central and southern California coast for the last 75 years. As a result of these combined efforts, the state has an abundance of baseline data that can help scientists understand the natural dynamics of the local ocean and shed some light on how these systems change in response to factors like climate change and human activity. These baseline data sets will play a really significant role in helping us understand the resulting changes to the ocean environment from these offshore wind developments. But even as comprehensive as these data sets are, there are still gaps in the baseline that, if not addressed within the next 5 to 7 years, might hinder our ability to assess the impacts of the floating offshore wind developments. The California Marine Sanctuary Foundation has been funded by the state of California to address these gaps in a coordinated and efficient manner, developing statewide offshore wind monitoring guidance. But this guidance hinges on scientists really getting specific about where these gaps in the baseline are. And to help address this need, I created a series of maps and a user-friendly data visualization tool through ArcGIS and R. Since not all monitoring programs measure the same things, I assessed the state of the baseline for these 12 different variables you see here on the right. For now, I'll just show you a few of the maps that I made. So let's start with seabirds and marine mammals. I did these 2 variables independently of one another, but their results were the same, so I'm just showing them together on one map. The wind energy area is in yellow, about 20 miles off the coast, and every other color on the map that you see represents a different monitoring program that records some measure of seabirds and marine mammals. This kind of visualization really helps us see the specific gaps in the baseline. If you look closely at the yellow, you'll see 5 monitoring programs that interact with the wind energy area. The program that covers the most area is NOAA's Rockfish Recruitment Ecosystem Assessment Survey, which is in blue. And between the 5 programs, they cover about 75% of the wind energy area, potentially leaving a small data gap in the northwest corner. East of the wind energy area is well covered by all of these 5 monitoring programs, but the west side less so. Many marine mammals and seabirds occupy large spatial ranges, and so while the wind energy area itself is decently covered with monitoring, some scientists might argue that baseline monitoring for seabirds and marine mammals should expand west of the wind energy area to also be comprehensive. Another variable that I looked at is that of seafloor habitat. The groundfish bottom trawl survey is in orange, covering the full extent of the Morro Bay wind energy area. And this is great. This is a lot of baseline data to have. But this illustrates a really important consideration, which is that once the wind farms are built, the turbines will be so densely packed that any ship-based monitoring surveys, like the one in orange, will actually not be able to access the wind energy area anymore. So this means that monitoring programs will need to change their methodologies to accommodate the infrastructure, and these changes have the potential to disrupt the continuity of these long-term data sets if the transition is not done really thoughtfully. So to help cover some of these gaps, it will be really important to have additional monitoring programs covering the same area as a safety net for dataset continuity. The last map I want to show you is for the results for both sea turtles and bats. Right now, none of the 14 monitoring programs I assessed are monitoring these 2 variables. And without some baseline data, we won't be able to identify any potential impacts to sea turtles and bats as a result of the floating offshore wind structures. So these are definitely two of the highest priorities for ramping up baseline monitoring before the wind farms are built in the next 5 to 7 years. These maps give you a broad sense of monitoring coverage and gaps in the baselines, but the real insights come when you actually interact with the data and use the data to answer specific questions. To make this work accessible, I collaborated with a colleague at one of the monitoring organizations, and we built a website for the public to interact with these data. And I'll give you an example of how someone might use this. So the wind energy area is in white. Say a local funding organization really cares about marine mammals and they are concerned about the impacts of these wind structures on whale migration. So they put out an RFP, which is a request for proposals, for some entity to monitor whale migration near the wind energy area. And a monitoring organization that's already applying for this grant might use this tool to inform their proposal. Say the organization is Cal Coffee. They already monitor marine mammals at one location in the wind energy area, the green dot in the lower right-hand corner. Originally, they may have written a proposal to expand their program to monitor the entire rest of the wind energy area. But using this tool, they can now see which programs also monitor marine mammals in the area. Their proposal will now focus on the areas that have no coverage, like the upper left-hand part of the wind energy area, making monitoring more efficient, both for Cal Coffee and for the funder. As another example, this tool will be able to help policymakers decide where to put future wind farm developments. Say a policymaker really cares about minimizing the impact of these wind developments on the ocean, and they know that the way to do that in the long run is to really study this first iteration of wind farms. They might choose to put this new wind development in a place that's already has really strong monitoring, baseline monitoring, because they want to make sure that we learn right now as much about the impacts of these developments as we can. So they take a look at this database and zoom out a bit and let the presence of monitoring along the coast partially inform their decision about where to put this next development. This assessment of baseline monitoring is just one component of California's offshore wind monitoring guidance, but it is the foundation for identifying and mitigating the impacts of floating offshore wind developments. By using long-term baselines to observe resulting changes in the ocean environment, policymakers and resource managers will have the information necessary to mitigate some of these impacts. As other states and nations consider floating offshore wind energy as an option, this framework will support them in developing it responsibly. In fact, just a few weeks ago, Maine actually announced that it's moving forward with its first floating offshore wind lease. I'm really excited to see how California's monitoring guidance and the precedent that it sets plays a role in Maine's decision-making, directly impacting a corner of the ocean that I know so well. As climate change intensifies and we look to the ocean for solutions, we have a responsibility to do so in minimally impactful ways. This framework sets a global precedent for comprehensive baseline monitoring and is a fundamental first step in the sustainable development of ocean-based renewable energy. This project would not have been possible without the steadfast support of so many people, some of whom are listed here. And I want to give a special thank you to my Capstone Advisory Committee for all of their thought partnership throughout this process over the last year. There are dozens of people who contributed their data and their programmatic expertise to this work. The website would not have been possible, full stop, without the support and guidance and mentorship and expertise of Ian Brengis. And I want to give a special shout out to the cohort and our program leadership for all of your encouragement and guidance this year. And lastly, so much gratitude to a wide community of friends and family, some of whom are here in this room and some of whom are online, without whom I would not be here in the first place. And so with that, I'll throw up the QR code for the website here with a caveat that it's much more friendly on a desktop than it is on your phone for now, so just beware. And I am happy to take any questions. Thank you so much.
Why bats?
The question was why bats, and that is a very good question. So essentially, I'll walk you through how I determined these different variables in the first place. I've got a couple slides for that here. Oh, sorry. There we go. So this was my sort of strategy for how to figure out what to monitor in the first place. And bats is one of them because it is one of the key groups that the California Marine Sanctuary Foundation had identified during their process as they're developing a statewide monitoring guidance. So I don't know too much about the science behind bat migration and sort of bat behavior, but it seems like there is reasons to believe that bats would be impacted by offshore wind. And so this has been one of the core pillars of the California Marine Sanctuary Foundation's process. So something that I wanted to make sure that I included in this work.
So one thing that I wanted to learn a little bit more about is how do all of these different monitoring programs communicate and share their data so that when someone wants to figure out the best place to create a wind farm, they can access all of the different data, even if it's from a different group?
Yeah, that's a really good question. The question was about how do all of the different monitoring programs communicate with one another and share data, and that is one of the recommendations from this process is to make that more streamlined and more efficient. Right now, it's the process of trying to gather all of this data was a wild goose chase, and it's definitely, there's a lot of room for growth and opportunity and streamlining all of the different data sets that are out there. And the hope is that, the East Coast has done a lot of amazing work on offshore wind, and they've got the Regional Wildlife Science Collaborative has developed an entire monitoring framework that pulls in all sorts of different monitoring programs and their data sets and makes it accessible in a sort of like one-stop shop framework. And that's the goal with this offshore wind monitoring guidance that the California Marine Sanctuary Foundation is running, is to try and set up a similar thing and make data set continuity and access much more accessible. So great question.
Question. Eliza, you mentioned that upwelling is one of the key systems to monitor for impacts from offshore wind. How do you think upwelling might be affected by these developments?
Yeah, great question. Questions about upwelling and how that might be affected, and I'll run through this quickly because I think we've got limited time. For those of you who don't know what upwelling is, it's basically a large-scale oceanographic process that is driven by consistent winds on the ocean, moving water and creating space for nutrient-rich waters to come up from the bottom of the ocean and sort of be made more available at the surface. And this is, the root of all of the biological productivity and biodiversity that we see in California. So there's a lot of questions about what happens when you actually remove that wind energy that's driving that system and turn that into electricity. What's going to happen to upwelling? So there was a study that came out just last year in 2023 that took lots of long-term data to model this. And on the left, you're seeing sort of the status quo baseline for wind and upwelling. And on the right, this is the model for what happens when you actually remove the amount of wind energy that is predicted to be removed by these different wind farms. The purple is showing a decrease in upwelling, and the green is showing an increase in upwelling as a result of the wind turbines. Just so happens that the Morro Bay wind energy area is smack dab in the middle of those two. So when I looked at upwelling in my process, there are a bunch of different variables and factors that go into upwelling. And these are the programs that measure some measure of upwelling. And there's a lot of monitoring that happens on the eastern sort of near shore side where we're expecting a decrease in upwelling, and a lot less monitoring that's happening on the offshore side where we're expecting an increase. So to be able to ground truth that and actually see sort of how this ends up playing out, where there's going to need to be a lot more baseline monitoring that happens in the next 5-7 years before wind farms are built to be able to really understand that process. But great question.
Thanks, Eliza.